So, welcome to the Learning Express. So, in the series of KMAP, uh, now we will look at the reduction of KMAP when don't care is given. So, I have two examples. One is for max terms and one is for min terms. So, this is min terms and don't care are considered with it. It is for max term and don't cares are considered. So I'll solve first example in this video and second example in next video. So okay. So what is don't care? So I'll simply solve this particular and you will get what is a don't care and how to use it. So first of all, we have to see the greatest min term. There is a 7. So I can write it using 1, 1, 1 means 3 variables. For 3 variables, K map with 8 boxes. 3 variables K map with 8 boxes. Also, we have to see in this don't care part. So out of don't cares and min terms, the greatest is 7. So 7 can be represented by 3 bits. It means 3 variables K map is required. So now, first of all, I'll draw the K map for 3 variables. This is the K map for 3 variables. Okay, this is the K map for 3 variables. Here A, B, and C. So important part is this. Whatever the numbers in min terms are available, first of all, fill them. What are the numbers available? First of all, fill them. So we have 0 means put 1, to 1, and 2, 1, and 7, 1. Okay. Now we cannot put 0 at all the rest terms. We have to put don't care. D stands for don't care at 4 and 5. So for put don't care at 4 and 5. So where is 4? This is 4. Put don't care here. And 5 is this. So put don't care here. Okay. So and rest place is 0. Rest place is 0. So what is the importance of don't care? Actually, when we have don't care is given, then we can group it. If possibly, can say largest group is possible, including this don't care, then make it. Simply make it. So I can say from this example, we have this possible quad. When we are including these don't care, this quad is possible. And before, this one was alone. But now this one can be involved with this particular don't care. So, and this particular one can be involved with this one. Okay. So this is squared. I will take as function 1 from here. And from this pair, I will take the second function f2. And from this particular, I will take as third function f3. So for this particular, I will draw 3 product terms and the product terms will be added. So we'll get the final function f, which is a sum of products. Okay. So what is f1? For this particular quad, f1 is, okay, so for this particular quad, f1 is okay. For f1 in this quad, both the terms, or can say this particular both the rows are involved, means a is available in both the forms. No, don't take the a, and particularly in these two columns, b is not changing while c is changing. So simply take b, but b is available in the form of complement form. Okay, so b is available in complement form. Simply write b here. Okay, and for f2, this squad is over because we cannot take a. It is involving both the rows, so a is available in both the forms, or can say a is changing, so don't take a, and b is not changing, so b is taken, but it is in complementary form. Similarly for f2, this particular row is involved, and this particular row a is in its pure form, or can say uh, its actual form, and these two columns are involved for this particular pair. So I don't care, will simply treat it as a one. because we are involving it inside the quad, inside the pair, so it will be treated as a one if we are considering SOP form. So for this particular pair, we have A in its actual form, and for these two columns, C is not changing. So dot with C. So dot with C. Now for F3. For F3, A is not changing and available in its complementary form. And similarly, when these two columns are considered for this particular F3, so can say B is changing, but C is not changing and available in complementary form. Okay. So finally, the function f is nothing but sum of f1, f2 plus f3. So it is b bar plus ac plus a complement b c complement. So this is the final function. This is the final function. Okay. So I think you will understand the meaning of don't care here. I will simply involve these don't cares inside the possible grouping. If it is quad is possible, I will involve it. If it is duplicate is possible, I will involve it. First of all, try to involve all the ones. You cannot do like this. You cannot do like this. If you have can say four cross are possibly. If something scenario is like this, and someone can say that you can involve. Suppose this is a scenario. Whatever the scene, I don't care. So suppose one is thinking like that. I will make this square. No, you cannot make this squared because only don't care cannot be considered. Don't care can be considered with one. You have to involve all the ones. So here, instead of this squared, only this duplicate is possible. So try to understand my can say what I am saying. You have to involve one at all. You cannot leave one as a. You cannot leave this one. We have to involve all the ones, and once all the ones are involved, and along with ones we can involve don't care. Okay, the next example I will take for POS, where I will involve these don't cares with zeros. So this is enough for this particular example, where I solved with min terms available with don't care. So this is enough for this video. Thank you.